All right, what up, homeboys and homegirls? It is Coach Jakes back with another chemistry video to make chemistry easy for you, or at least easier. All right, so we're still on our gas law series. Here we're talking about Gay-Lussac's law. All right, it's actually two different scientists. If I'm not mistaken, I think they collaborated and came up with these results. I'm not exactly showing all the details. But what I am sure of is in this law, we are examining the relationship between pressure and temperature. So what we're saying is that the temperature will impact the pressure, okay? Again, this is like a before and after, initial versus final. All right, so we're gonna have a set box. Our boxes are approximately the same volumes. I tried to draw them to match each other. If they're a little bit off, pray for me. All right, so what we see here is at the beginning, initially we have a gas at 200 Kelvin that has a resulting pressure of 3 atmosphere. So we're saying that if we change that change the temperature, if we change the temperature from 200K to 400K, then the pressure will go from 3 atmosphere to 6 atmosphere. So because as one increase, the other one increase, we already know that they are going to be directly proportional, because as one goes up, the other one goes up. If the temperature went down, then the pressure would also go down. So that still makes them directly. And proportional, again, means that they would change at the same ratio. So if this one doubles, that one doubles. If the temperature tripled, the pressure would triple because it's directly proportional. All right. So the formula that represents this relationship is P1 over T1 equals P2 over T2. All right, and if you didn't notice, as long as you're writing your formulas as fractions, your temperature is always under the bottom. When you look at Boyle's law, the pressure and the volume are actually multiplied because there's no temperature. But temperature is always in the denominator or the bottom of the fraction. All right, now I got 2 practice problems here, so let's go over those real quick. All right, in a non-elastic container, that simply means the volume won't change, but that blah, 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 blah. Pressure of 58 kPa, so we know that's going to be a P. At 46 degrees Celsius, we know that's a T. If the temperature is increased, so if it's increased, that means it started here, so that's going to be our T1, and these are together, so that's going to be our P1. So now it says if the temperature is increased to 100 degrees Celsius, that will be our T2. What would the resulting pressure be? So we're looking for P2. So then we're going to go P1, T1. All right, P2, T2. Now, some of y'all might not need this step. If you don't, that's cool. You can just go ahead and go to the math. But for the people who need it, I'm going to do it this way. All right, so P1 is 58 kPa. Our T1 is actually 46 degrees Celsius, and that's in Celsius. We're going to have to address that because we math in Kelvin. We can measure in Celsius, but we need to math in Kelvin. All right, P2 is our X. And our T2, I almost wrote T2. Don't mind, I'm using a little paper towel, don't mind that. But our T2 is 100 degrees Celsius. All right, so again, that's in Celsius. That's a problem. So we need to convert that. So if you remember, in order to convert temperature from Celsius to Kelvin, you add 273 to the Kelvin. If y'all hear yelling, that's my kids, they playing the game. I think they're actually playing like Injustice or something, so probably pretty intense. 373.15 K here, and then again 273. All right, we get 9, 11, 319. Is that what y'all got? 319 K? 0.15. 3, I don't like that. 3, 1. I gotta get some fine tip markers because these 3.19, there we go, good. So, knowing that we have pressures and temperatures, we're going to use P1 over T1 equals P2 over T2. I live near the airport too, so if you hear planes and stuff, my bad. All right, so P1 would be, we're going to replace our numbers. P1 would be 58. T1 would be 319. Equals P2 is our X over T2, which is 373.15. All right, so at this point, you can cross multiply. So you would end up with 58 times 3. See, my writing so bad, I can't even read it. 373, yep. So that'd be 58, 373.15 equals 319.15x. I'm going to run out of room. 319.1.15x. You just got to know that 3.19. I'm going to erase it. I'm going to move it over, right? Yeah, we're good with this, so I'm just going to erase that bottom part. So I need more space. I don't want y'all to be confused. 58, 373.15 equals 319.15x. There we go. All right, and then when you multiply here, divide by that, x will be equal to 67.813, whole bunch of stuff, but then we got to look at sig figs. All right, so we're at 2 here, only 1 there. So that would end up being 70. So that would be equal to 70 pressure kPa. So I ran out of room. It took a little bit more space than I anticipated. Again, my bad with the kids. All right. And let's see if that makes sense. Did our temperature increase? Yes. Went from 46 to 100. So because it's directly proportional, that means our pressure should also increase. Our pressure went from 58 to 70. So that makes good logical sense. All right. And then for our last practice problem on this one, we have on a hot summer day, the pressure in the car has increased from 4 to 9. So it started here at P1, ended at 9.7. That's our P2. If the highest temperature was 346 K, so that's out. That's a T. All right, now it says the temperature in the it says the pressure increased. So if the pressure increased, we know the temperature also increased. So that means the highest temperature would be our T2. Then we're looking for the lowest temperature would be our T1. So we got P1 equals T1 equals P2 equals T2 equals. And then we need to plug in our numbers. For P1, we had 4. Right here, P1 was 4. Our P2, was 9.7. T1 is what we're looking for, X. Then our T2 is 346. Oh, I touched. You don't see that? That's horrible. I touched the blue with the red. I don't like that. All right, so we got P1 over T1 equals P2 over T2. Plug in our numbers. So we have 4 over X equals 9.2 over 346. All right, all we did was P1, 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 T1, 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 P2, 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 T2, T2, T2. All right, then you're going to cross multiply, so you get 346 times 4 equals 9.2x. By the way, I don't cross multiply. I'm doing that because that's what my kids like to do. I would just handle the fraction and then put it underneath and divide. But I do this because it helps y'all. All right, so you can multiply here, divide by 9.2. And so then x equals 142.6804. All right, but then we go look at sig figs. I got 1, 2, and 3. That means our answer can only have 1. All right, so we're at 1.4. Oof, that's a huge change, but it is what it is. That would be, because the 4 doesn't make the 2 go up. The 4 doesn't make the 1 go up to 2. So we end up with 100 temperature. Okay. All right. Now, if your teacher's not asking sig figs, then don't worry. But make sure you talk to your teacher and see what they want. All right, and that is Gay-Lussac's Law. Like this video if it helped you out. Make sure you share it with your friends, people in your class, your group members, your teammates, your parents, your teacher, whomever this could help. All right, we got some worksheet videos coming soon. Y'all take care. Peace.